Good morning, students. In the last class, we have already learned about elementary transformation and how to find the inverse of any square matrix by using elementary transformation. For today, let's find the inverse of this matrix A by using elementary row transformation. Elementary transformation da makal ani lay. Row transformation haiba maga, column transformation haiba maga ko. Row transformation use toraga sigi matrix A sigi inverse putose. Step number 1, write square matrix A. Write all the elements of matrix A. This is step number 1. Then step number 2, A will be equal to I multiplied by A. Write A. All the elements of A are 1, 2, 3, 2, 5, 7, minus 2, minus 4, 5. Then write identity matrix. Identity matrix of order 3, 1, 0, 0, 0, 1, 0, and 0, 0, 1. Multiply by this matrix A. Kuina mamang the algorithm tamgiba kanda first element A11 se element lies in first row in the first column should be equal to 1 niko. Sige matrix ke element naam se check to kanda element A11 se 1 tare. Do this step number 1 se skip tore. By using this element 1, make the corresponding element this 2 and the minus 2 will be equal to 0. See use toraga anisa 0 tana ba same doiniko. So this plus 2 lies in second row. We have to apply the operator R2 tends to R2 plus minus 2 times of R1. First, all the elements of first row should be multiplied by minus 2. Here the number is plus 2 and the scalar should be minus 2. Since minus 2 plus 2 is equal to kya tarakani 0 ka. Nisigi first row ki element mein humse minus 2 na multiply tore na khale and adding to the corresponding elements of second row, and this operator is to be applied on second row. Chida minus 2 na multiply tore se 1 into minus 2 plus 2 is equal to 0. 2 into minus 2 minus 4 plus 5 is equal to 1, and 7 into 3 into minus 2 minus 6 tareko. Minus 6 plus 7 is equal to 1. Nang first row, third row sense later, first row ito ay 1, 2, 3. Third super row sisu ito siko minus 2, minus 4, and minus 5. Then we should apply this operator on right hand side also. First, we have to multiply all the first row by minus 2 and adding to the corresponding elements of second row. 1 into minus 2 plus 0, which is equal to minus 2. 0 into minus 2 is 0 and plus 1 is equal to 1. 0 into minus 2 is 0 and 0 plus 0 is equal to 0. Then write all the elements of first row and the third row. Sidanangi step number ani set kreko. 1 tare is 0 tare. Then make this element minus 2 is equal to 0. Here the given number is minus 2. The scalar should be plus 2. Nangi minus layer magadi plus oiganiba. Plus layer magana minus oigadabuka. 1 sida koina hana kaina multiply torani. All the elements of first row multiply by plus 2 and adding to the corresponding elements of third row we get. First, all these elements should be multiplied by plus 2. 1 into 2. Ang nasida si apply to risa kaide apply to gani third row dani ko na first row ga second row ga sense later. First row ga second ga sense later bani na magi elements ito 1 2 3 0 1 1 ire som gi samana na 1 0 0 minus 2 1 0 ire ko. Then for third row, first multiply elements of first row by plus 2 and adding to the corresponding elements of third row. 1 into 2 plus 2 minus 2 is equal to 0. 2 into 2 is 4 and 4 plus minus 4 is equal to 0. 3 into 2 is 6 and 6 plus minus 5 is equal to 1. Then apply this operator on right hand side also. 1 into plus 2, 2. 2 plus 0 is plus 2. 0 into 2 is 0, 0, and 0 into 2 is equal to 0, and 0 plus 1, it will be equal to plus 1. 1 tare, 0, 0 tare ka. Then check the elements of second row. Second row sector 0 1 1. Here the diagonal element A22 is equal to 0. 0 tarama this step skip tore ka. By using this element A22 in second row, make the corresponding element 2 and 0. Magi mapada layrise sigi 2 siga 0 sigan 0 se masana 0 tare ka. We need to make this element 2 equals to 0. Sigi 0 gata manahan ba adu khak tangai reba. By using kaisi sinagani second row. Second row use the record. Since this plus 2 lies in first row, we have to write R1. Tends to write R1 plus use R2. R2 season aduiniko. Scalar sange. If the given number is plus 2, then scalar will be minus 2. Then we get first row the apply tawdine ahanbada second row the minus 2 na multiply tawro. All the elements of second row multiply by minus 2. 0 into minus 2, 0, 1. 1 tareko. 1 into minus 2, minus 2. Minus 2 plus 2 is equal to 0. 1 into minus 2, which is equal to minus 2 plus 3 is equal to plus 1. So I'm pangiko. Then apply this operator on right hand side also. Minus 2 into minus 2 plus 4, 1 is equal to 5. 1 into minus 2 plus 0 is minus 2. 0 into minus 2 is 0. 0 plus 0 is 0. Then write all the elements of second row and the third row. So then the operator lore. See the 1 layer ko. Then check the elements of third row. Elements of third row are 0, 0, 1. Here the diagonal element A33 is equal to 0. By using this element 1, make the corresponding element 1 and the 1 is equal to 0. Still a river 1, 1 say use the name. Sida sige nangi matrix equation se itoy ko. 1, 1, 1 pireba. Adudi se chap manabore. Chap manatardi am naire ko. Applying R1 tends to R1 minus R3. Siya namangan ko. Since this one lies in first row, and we have to subtract all the elements of the third row from elements of first row. 1 minus 0 is 1. 0 minus 0 is 0. And 1 minus 1 is equal to 0. 5 minus 2 is 3, minus 2 minus 0 is minus 2, and the 0 minus 1, it will be equal to minus 1. Write the elements of second row and the third row. Here, check the elements of this matrix 1, 0, 0, 0, 1, 1, and 0, 0, 1. C1 later, C1, C 0, 7, C. Since this one lies in second row, then we have to apply the operator R2 tends to R2 minus R3. Subtract elements of R3 from elements of R2. This is elements identity does a record. Sigi second row the third set subtract 3 minus 2 minus 1 are the elements of first row. We have to apply this operator on second row only. Minus 2 which is equal to minus 4. 1 minus 0 is plus 1. 0 minus 1 is equal to minus 1. Then write all the elements of third row 2, 0, 1. Since all the elements of matrix given in left hand side is equal to identity, therefore the inverse of the matrix A will be equal to this matrix, whose elements are 3, minus 2, minus 1, minus 4, 1, minus 1, and the 2, 0, 1. Next, let's come to exercise 3.4. Using elementary transformation, find the inverse of the given matrices. Matrix mamam pire ko asdagi question number 15 ga 16 ge apply tors. Question number 15, given matrix ampere. We have to find the inverse of this matrix by using elementary row transformation. Row transformation sijinaragan hotsiko. Let A represent the given matrix whose elements are 2, minus 3, 3, 2, 2, 7, 3, minus 2, 2. For row transformation, matrix A should be equal to I multiplied by A. Right elements of A and the right elements of identity matrix. And ito eko. For Roman number 3, see the elements in Zana check the elements 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2 have a neighbor. See say 1 talaga anima 0 chat kadam neighbor. See apply to dring it. First 2 uses sub manarabanina, second row the first row log to osiko. Applying R2 tends to R2 minus R1 and R3 tends to R3 minus R1. See apply to wagi maram di kay gana 3 dagi 2 log to pumatam da kay fangi 1 hay basi fangi ko 1 tana bay damagta sigo operator say apply to rene. First R2 tends to R2 minus R1. Write all the elements of first row 2 minus 3, 3, 1, 0, 0. See apply to siko. Second row dagi first row kay 2 minus 2 is equal to 0. 2 minus 3 minus plus, and 2 plus 3 will be equal to 5, and the 3 minus 3 which is equal to 0. Then apply this operator on right hand side. 0 minus 1 which is equal to minus 1. 1 minus 0 is 1. 0 minus 0 is equal to 0. Then apply this operator. R3 tends to R3 minus R1. Third row dagi first row se khaidokani buko. First row khaidodi 3 minus 2 which is equal to 1. Minus 2 minus minus 3, minus minus plus 3 minus 2, it will be equal to plus 1. 2 minus 3, 2 minus 3, which is equal to minus 1. Then for this case, 0 minus 1 is equal to minus 1. 0 minus 0 is plus 1. And the 1 minus 0, it will be equal to 1. Then write matrix A. Matrix A ito ko. Sida 1 layer, sida na 2 layer ko. Ani is interchange daw to se. Then applying or interchanging first row and the third row, we get 1, 1 minus 1. The first row sina third row oigraniba, and the third row becomes first row. And is on thong na ko 1, 1 minus 1, 2 minus 3, 3. Sigisu sina first set currency for sina third term zatlaniba. Minus 1, 0, 1, minus 1, 1, 0, and the 1, 0, 0. Si later ko. Sida 1 later. Si 0 tazare, si 2 se 0 zatlalo. Sigi 2 se kai de lies the way third super row the lay ko. So applying R3 tends to R3 plus koina si the 1 se 0 si the lay 2 se 0 set ke hai taragade 1 the minus 2 na multiply to ganeva. First multiply elements of the first row by minus 2 and the adding to the corresponding elements of third row, then we get this element 2 will be equal to 0. So apply this operator. 1, 1 minus 1, first row, second row, ireko. Third row, 1 multiplied by, si mayam sida kaina multiply tawni, minus 2 na. 1 into minus 2, minus 2. Minus 2 plus 2 is 0. 1 into minus 2, minus 2. Minus 2 plus minus 3, which is equal to minus 5. Minus 1 into minus 2, minus minus plus 2 plus 3 is equal to 5. Minus 1 into minus 2 plus 2 dareko, 3 dahapadi. Minus 1 into minus 2 plus 2. 1 the half is 3 tare. 0 into minus 2. 0 plus 0 is 0. 1 into minus 2. Minus 2. Minus 2 plus 0, which is equal to minus 2. Then write matrix A. Chi 1 ta zagre 0 0 tare ko. Mathang da koina kai apply to gani. Sigi se 1 ta handui na first row sizinagra dise fix tawgre ko leng bayadre ani sidagi anka hotui ne ba. This is the 5 havam layer is the minus 5 havam layer ko. And is a plus tau sinara 0 salalis. Then applying R3 tends to R3 plus R2. Nangi third super rows the third row ga second row ga plus tau to ko. Sis the absela 1, 1 minus 1. 0 plus 0 is 0. 5 into minus 5, 0. 0 plus 5 is equal to 5. So apply to ko. Second row ga third ka gi plus the third the e ga minus 1 plus 3, 2. 1 plus 0 is 1. 0 plus minus 2 is equal to minus 2. Hausik nangi element A2 2 se 1 dahan doi ne. 1 dahan baka nang si interchange to basu yadre operator rule to basu atoba operator ma'am sizina basu yadre ko. Kari khaktang dama se 1 taba ngami hairadi. All the elements of second row si da kaina divide rakanda 5 na divide rakanda si divide to se ko. Then applying R2 tends to R2 divided by 5. 1, 1 minus 1, 0. 5 divided by 5 is 1. 0 by 5 is equal to 0. Minus 1, 0, 1. All these elements should be divided by 5. Minus 1 by 5, 1 by 5, and 0 by 5 is equal to 0. Then write third row. May ito ko. Matrix equation C pangre C1 tare corresponding elements is 0 ga mathaki 1 siganiba. Sigi 1 se 0 salalasi by using this element 1 in the second row. Second row use to gadam ne handak. First row mug use to second row mug use to last and third row use to duni ko. Second row applying this one lies in first row, so we have to apply the operator on first row. Then by using the elements of second row use to neba. R1 tends to R1 minus R2 since 1, 1 are equal elements. Elements is chakmana vanina subtract na beare ko. First row the second row kaito. 1 minus 0 is 1, 1 minus 1 is 0, minus 1 minus 0 is minus 1. Then write all the elements of second row and the third. Apply this operator on right hand side also. Nangi minus 1 am layer ko. Minus 1 minus 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 plus 1 by 5. LCM lore 5 tare. LCM minus 1 into 5 is equal to minus 5 plus 1. Difference between the minus 4 by 5 and 0 minus 1 by 5. It will be equal to minus 1 by 5 and 1 minus 0 is equal to plus 1. Second row and the third row ireko. C 1 tare 0 0 later 1 later 0 0 chale ko step 5 habam le ho C 5 se 1 ta na same of C 5 se 1 ta han ge hai taragadi we have to divide third row by 5 5 na divide torani ko 1 0 minus 1 see the 5 na loin divide to 5 by 5 is 1 2 by 5 1 by 5 and minus 2 by 5 multiply by matrix A. Here the diagonal element A33 is equal to plus 1. By using this element 1 in the third row, make the corresponding elements are 0. 0 sale minus 1. Since plus 1 and minus 1 is equal to 0, then we have to apply this operator. R1 tends to R1 plus R3. Nangi first row si the first row ga third sub row si ga plus tawrasi ko ani se plus taw sinare si hapsin mamatamda 0 sale. Do the energy plus taw do se 2 by 5 plus minus 4 by 5 ne 2 by 5 plus minus 4 by 5. They have same denominator. Find the difference of numerator. 2 minus 4. It will be equal to minus 2 by 5. And 1 by 5 plus minus 1 by 5 which is equal to 0. Minus 2 by 5 plus 1. Matang sina minus 2 by 5 plus 1 niko. LCM lorena kaladi 5 tare. Minus 2. 1 plus 5 is equal to 5. Minus 2 plus 5 which is equal to 3. And 3 divided by 5. These are the elements of first row. Then write all the elements of second row and the third row. If there is a matrix A, this matrix A multiplied by this matrix is equal to identity. Matrix A, the sige matrix na multiply to was identity tare ko. The matrix A gi inverse kay tarani. Sige matrix A orani. A gi inverse. Therefore, inverse of A is minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, and 2 by 5. Therefore, for Roman number 1, A inverse will be minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0. Last element are 2 by 5, 1 by 5, and minus 2 by 5. So, main taraga ko na first the B riba matrix 2 gi inverse puto pair ko. Next for question number 16. Question number 16, the matrix sum pair. This matrix is represented by A. A 1 3 minus 2 minus 3 0 minus 5 2 5 0. So minus matrix sum pair ko. By using elementary row transformation, find the inverse of this matrix. For row transformation, step number 2, matrix A should be written as matrix A I multiplied by A. So my ito kaniro. Sina step number 2, matrix A. First write all the elements of A. 1 3 minus 2 C ko identity matrix C to C element naam se sector. First row, second row, and the third row. First row the 1 layer me ko. Step number 1 skip to gre 1 later gadi sigi 1 se use to do ni ko. By using this element 1 in A11. First row, first column the layer 1 se use to raga make the corresponding element minus 3 ga 2 was 0 sal hello. Adudi handak si double easy ko anang operator se. For second row the D1 should be multiplied by scalar 3. Scalar 3 iranib. For second row, R2 tends to R2 plus 3 times of R1. Then for third row, plus 2. Scalar should be minus 2. See operator se apply to sika for second row gyana tawra se first write all the elements of first row erase 1 3 minus 2 1 0 0. For second row, elements of first row should be multiplied by 3 and adding to the corresponding elements of second row. First row ki elements are 3 na loy multiply to say 1 into 3 is 3. 3 plus minus 3 which is equal to 0. 3 into 3 9. 9 plus 0 is equal to 9. Minus 2 into 3 is minus 6. Minus 6 plus minus 5 is equal to minus 11. Then for right hand side 1 multiplied by 3 is 3. 3 plus 0 is 3. 0 into 3 is equal to 0. 0 plus 1. J1 tareko 0 plus 3 0 plus 0 hapsiladi 0. Nang second row gise left to right to apply to bulare. Then for third row, first multiply elements of first row by handak the scalar se kayo ni use to gani scalar se minus 2 and use to rani ko. Duga kanada hap kani adding to the corresponding elements of third row. 1 into minus 2 plus 2 is equal to 0. 3 into minus 2 minus 6 plus 5 which is equal to minus 1. Minus 2 into minus 2 minus minus plus 4 tare ko 4 is 0 dhapadi 4 tare. Then apply 4 dum tazare. Apply this operator on right hand side. Right just to apply to say 1 into minus 2 plus 0 is minus 2. 0 into minus 2 0. 0 plus 0 is 0. 0 into minus 2 0. 0 plus 1 it will be equal to plus 1. Then write matrix A 1 0 0. Step number 1 2 bao loi kre ko. Then make this corresponding element in A22 sigi nangi element A22 diagonal element A22 se 1 tahan duine ba 1 tahan ba se nang first row di use tograbani sijina ba adre ko second row ga third row ga ne aduna sigi minus 1 sida aina 8 haibam na multiply tawraga 9 da hapadi 1 phangi ba ko. First we multiply elements of the third row by plus 8 and adding to the corresponding elements of second row we get the diagonal element A22 is equal to 1. So apply this operator on the above matrix equation and now write 1 3 minus 2. See matrix apply to siko. Third row subasida 8 na multiply to 0 into 8 0 0 tare ko minus 1 into 8 minus 8 plus 9 which is equal to 1 and 8 into 4 32 tare. Nangi 32 sa minus 11 da hapadi kay gamana ne 21 leme ko plus 21 lem hore plus 21. So nakanda so easy minus 2 into 8 minus 16 plus 3 which is equal to minus 13. 0 into 8 0 1 1 ta 0 ko 1 into 8 8 0 apadi 8 tare. Write all the elements of that row. 1 0 0 se 1 lere minus 1 lere 3 lere ko corresponding elements se 3 ga minus 1 ga lere ba. By using the element 1 in the second row, make the corresponding element 3 and the minus 1 equals to 0. For first row, apply this operator R1 tends to R1 plus elements of second row multiplied by minus 3. Here the scalar number is plus 3 and the scalar should be minus 3. Then for third row the d plus 1 plus minus 1 is equal to 0. Scalar should be plus 1. Scalar se 1 nena khanbe are ko. Second row ga third ka plus to bakana nang 0 chat level. And 1 chian apply to say R1 tends to R1 plus minus 3 R2 minus 3 na naloi multiply to 0 into minus 3 0 plus 1 1 tare ko 1 into minus 3 minus 3 plus 3 0 21 into minus 3 kya gamana ne 21 the minus 3 3 minus 63 minus 63 minus 2 it will be minus 65. Apply this operator on right hand side also. Minus 13 into minus 3 minus 13 into minus 3 kya ta ne 9 3 39 minus minus plus tare ko 39 plus 1 which is equal to 40 nang 0 40 se plus 1 phange 1 into minus 3 plus 0 is minus 3. 8 into minus 3 minus 24 plus 0 which is equal to minus 24. Sibo phange ko nang sigi ahanbagi operator si loire second gi second di koina third suba term sida third suba row sida second row duga third suba row duga plus torasi ko 0 plus 0 0 1 plus minus 1 0 21 plus 4 25 minus 13 plus minus 2 minus 15 1 plus 0 is 1 and 8 plus 1 is equal to 9. Matrix A reko step last ki si kaktangare diagonal element A33 se check toro 25 later ko 25 se 1 tahan doini 1 tahan ge tar we should divide all the elements of third row by 25. Third super row se 25 na divide tor 25 to minus 15 nangi minus 15 the 25 na divide tor 5 3 15 and the 5 5 25. Remaining element is minus 3 by 5 1 by 25 and 9 by 25. By using this element 1 in third row, make the corresponding element 21 and minus 65 is equal to 0. Operators for first row will be R1 tends to 65 into R3. Since the given number is minus 65, scalar should be plus 65. Then for second row, R2 tends to R2 plus minus 21 R3. Given number is plus already. scalar se minus 21 oiniko. And we should apply this operator on first row. First row de apply torsi. Sima 100 chatle khangiko. Yuna nang na lag to rise. Sige case sida. All these elements minus 3 by 5, 1 by 25, 9 by 25 multiply by 65 and adding to the corresponding elements of first row. The elements are minus 3 by 5, 1 by 25, 9 by 25 niko. The 65 na multiply door. 5, 65, 13 minus 13 into 13 is minus 39. Sige minus 39 se kanada hapkani 40 dako. Minus 39 plus 40 is equal to 1. We get this element 1. 1 by 25, second element, multiplied by 65. We get 13 divided by 5. 13 by 5. This 13 by 5 should be added to minus 3. We get 13 by 5 minus 3. LCM lower. LCM is 5. 13 minus 5 into 3 is 15. And minus 2 divided by 5. Sige element minus 2 by 5 si phangi ko. Last 9 by 25 into 65. 5 na divider, we get 13 by 5. 9 into 13 is 117. Denominator is 5. 117 by 5 is added to minus 24. It will be equal to minus 24. Then find the LCM of these terms. LCM is 5. 117 minus 5 into 24 is 120. And their difference is minus 3 by 5. So, minus 3 by 5 hangi ko. Tagi second row gisemu yengse. Second row then all the elements of the third row multiply by minus 21 and adding to the corresponding elements of second row. Mamangi sina first row dahap. Handang na kay dahap kani second row dam hap siko. First row third kise minus 3 by 5 into scalar is minus 21. Minus minus plus 3 into 21 minus 63 by 5. Chikana dahap chen gane. Minus 13 dahap kani minus 13. Their LCM is 5. 63 minus 5 into 13 is 65. Their difference is equal to minus 2 by 5. We get this element minus 2 by 5. Then mathang na nang natawdu se 1 by 25 into minus 21. 1 by 25 into minus 21. Cancel the adre ko. Their product is minus 21 by 25. This product should be added to plus 1. Plus 1 half to ko. Plus 1 half LCM is 25. Minus 21 plus 25 is equal to 4 by 25. We get this element 4 by 25. For the last case, 9 by 25 multiplied by minus 21. 9 into 21 is minus 189 by 25. This number should be added to kanada half kani plus 8 half to ko. Minus 189 by 25 plus 8. Their LCM is 25. Minus 189 plus product of 8 and 25 is equal to 200 and their difference is 11 by 25 and we get this element. Then write all the elements of the third row. Third row ginang elements ito eko. Sina matrix kya suboy do no? Sige matrix A sida sige element sina multiply to was identity matrix or do the secret darane. This is the inverse of the given square matrix A. Square matrix A dugi inverse where any. Therefore, A inverse are ng element naam sa ito ko. Next, using elementary column transformation, find the inverse of the matrices. Then the matrix ani khangali ko. Matrix A Roman number 1 and 2. Handak na kay sisinaba ng column transformation use tawduni ko. For column transformation, A, first write matrix A to ko. For column transformation, this matrix A should be equal to A multiplied by I. I sinanang handak na write at hangrani ba. Element A ire ko. Identity matrix 1 0 0 0 1 0 and 0 0 1. Applying C1 tends to C1 and C2 interchange the C interchange the way maram di kay gino handak di kalam dalani. First column, second column, third column lagdoini. Step 1 dahan doini. Step 1 dahan gay tardi column 1 ga column 2 go on thok narsiko. Interchanging first column and second column, we get first column becomes second column and the second column becomes first column. 1 2 1 minus 1 0 som da su on thok nare. Ire ko si 1 phange si minus 1 ga si 2 ga si 0 salan jeb. By using this element 1 in first column, make the corresponding element -1 and this to 0. First for second column, 1 plus -1 is equal to 0. Operator for second column will be C2 plus C1, and third column gidi C3 tends to C3 plus. First, this element plus 1 should be multiplied by -2. C plus 2 layer money -2 na multiply towards. Apply to siko 1 to 1 ito 1 plus -1 0. 2 plus 1 is 3. 1 plus 3 is equal to 4. This is samana na 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. Second row the iduini ko. Third super row da na kamain tawgani. Column 1 da and the -2 na multiply to. All the elements of the first column multiply by -2. -2 na multiply tawgadam mathak sidoini. All the elements of the first column multiply by -2 and adding to the corresponding elements of third column. 1 into -2 plus 2 is equal to 0. 2 into -2 -4 plus 3 which is equal to -1. 1 into -2 plus 1 is equal to -1. Sidamu -2 na loy multiply to siko 0 0 tare 1 into -2 -2 fange 0 into -2 is 0 plus 1 da hapadi 1. Sida step ani loy kreko. C1 tagre 0 0 chatle ko mathang na nang tawdui se sigi element se 1 tahandoine ba. Make the diagonal element A22 is equal to 0. C 0 tahan gai tar di -1 si the 2 na multiply tar 1 into -2 -1 into 2 se -2 ne 3 da pa di 1 phange ko. Then applying column 2 tends to column 2 plus 2 times of C3. Sigi si the plus 2 na multiply tar. -1 is 0 0 chatle -1 into 2 -2 plus 3 which is equal to 1. -1 into 2 -2 plus 4 plus 2 phange ko. Sida su 2 na multiply to 0 into 2 0 plus 1 is plus 1. -2 into 2 -4 plus 1 which is equal to -3. And 1 into 2 is plus 2 plus 0 is equal to 2 phange ko. C1 tagre 0 0 tagre C1 phange ko. Corresponding elements are plus 2 and the -1 C plus 2 se kai de lies the way column 1. C -1 se kai de lies the way column 3 da ko. C1 se use to doing. Column 1 tends to column 1 plus column 2 multiplied by -2 minus some change. But for column 3, second row plus third row, however, this element is equal to 0. So we have to apply this operator on column 3. Sigi element naam se -2 na multiply to 0 1 1 chatle 1 into -2 plus 2 is 0. 2 into -2 -4 plus 1 is -3. This is for column 1. 1 into -2 -2 plus 0 is -2. -3 into -2 minus plus sida hapadi 7. 2 into -2 -4 -4 se nang 0 da hapadi kya tare -4 ko. Column 2 gi loigre ko column 1 gi loigre column 3 gi moholas. For column 3, find the sum of column 2 and column 3. 0 plus 0 0 1 plus -1 0 2 plus -1 1 1 plus 0 is 1 -3 plus -2 -5 2 plus 1 is equal to 3. Last key steps is C check taurasiko. Here the diagonal element A33 is equal to nang 1 tare. C1 tare dilare ko. Sigi corresponding element 2 ga -3 ga 0 salalu. -3 lies in first column and the plus 2 lies in second column. Sina first column da, sina second column da. Nang column 3 iresiko. -3 here the scalar should be +3. +2 here the scalar should be -2. Sita mo apply to apply this operator on column 1. First elements of C3 multiply by 3. ꯁꯤ ꯃꯄꯥꯁꯦ ꯁꯤꯗ 3ꯅ multiply ꯇꯧꯕꯗ ꯁꯤꯒꯤ ꯃꯄꯥꯁꯤꯗ 3ꯅ ꯁꯤꯃ ꯑꯗꯨꯝ 0 ꯆꯠꯂꯦ ꯈꯪꯉꯤ 1 into 3 3 minus 2 1 ꯇꯥꯔꯦꯀꯣ minus 5 into 3 minus 15 plus 7 is equal to minus 8. 3 plus 3 is 9. 9 plus minus 4 is equal to plus 5. Then for second row, elements of C3, it should be multiplied by minus 2. Sige mapase, handak na minus 2 na multiply taurani, and adding to the corresponding elements of second column. 1 into minus 2, minus 2. Minus 2 dareko. Minus 2 plus 1 is equal to minus 1. Minus 5 into minus 2, 10. 10 plus 3 is plus 7. 3 into minus 2, minus 6. Minus 6 plus 2 is minus 4. Write all the elements of the third column. Matrix A empirical. Matrix A sige matrix na multiply to sa identity fangiba by the definition of inverse of any square matrix, and therefore A inverse will be this matrix. For Roman number 2, matrix A whose elements are 3, minus 1, 1, minus 15, 6, minus 5, 5, minus 2, plus 2. Sige se kay putokani inverse puto by using elementary column transformation. Write A is equal to A multiplied by I. Silo ito eko. Sta kala se nangi column transformation already kamain tawgani hebsego. Sida 1 legre, sida na 3 legre ko. Adudi kana han onthok na rani. Column 1 with column 3 interchange taro. 1 minus 5, 2, 3 minus 15, 5. Somgisu onto eko. Interchange first column and second column, we get the diagonal element A11 is equal to 1. By using this element 1, make the corresponding element minus 1 and 3 equals to 0. Si 0 gama na ina prove tawro ko. Operator kalo. Operator se kamain kan gani. 1 plus minus 1, 0. So, operator is C2 tends to C2 plus C1 for C3. C3 the scalar sange ko. Plus 3 hana layer mavanina, top scalar se minus 3 hana lower. Apply to sige se column 2 hana fast row column ire. 1 plus minus 1 is 0. Minus 5 plus 6 is plus 1. 2 plus minus 2, 0. So, yang siko 0 plus 0, 0. 0 plus 1 is 1. 1 plus 0 is plus 1. For third column, elements of the first column multiply by minus 3. Sige mapase minus 3 na loy multiply to with them. And adding to the corresponding elements of third column. Minus 3 into 1, minus 3. Minus 3 plus 3 is 0. Minus 3 into minus 5, minus minus plus 15. Minus 15 is 0. 2 into minus 3, minus 6. Minus 6 plus 5 which is equal to minus 1. For right hand side, 0 into minus 3, 0. Plus 1 is plus 1. 0 into minus 3, 0. 0 is 0. 1 into minus 3, minus 3. Plus 0 is equal to minus 3. Simong the fangi ko. 1 layer, 0, 0 layer. Here diagonal element A22 is equal to 0. And one of the corresponding element is 0. Then we have to make this element minus 5 is equal to 0. Si katangare nangi minus 5 sa 0 gamanahan ba case katangare ko. Minus 5 se kaide lies the way first column. Since the number is minus 5, scalar should be plus 5. First elements of second column multiply by 5 and adding to the corresponding elements of C1. 0 into 5, 0. 1 darego. 1 into 5, 5. Minus 5 is 0. 0 into 5 is 0. Plus 2 is plus 2. 0 into 5, 0. 1 into 5, 5. Plus 0 is plus 5. 1 into 5 is 5. 5 to 1 hapsiladi 6 darego. Then write all the elements of second column and third column. Sa si sek daw sika. Minus 1 lerame. Minus 1 se use the raga 2 se 0 sal hello. By using this element minus 1 in third column, make the corresponding element plus 2, 0. For this case, the scalar should be plus 2 since plus 2 and a minus 2 is equal to 0. First, all the elements of the third column multiply by plus 2 and adding to the corresponding elements of Kanada Hapkani. column 1 da hapani ko. Minus 1 into 2 is plus 2. Plus 2 minus 2. Minus 2 plus 2 which is equal to 0. Tapos idahani siya chap manare. 1 into 2 is 2. 0 da hapadi 2 dare ko. 0 into 2 is 0. Plus 5 is equal to 5. Minus 3 into 2 minus 6. Minus 6 is 6 da hapadi kya darani 0. Right, all the elements of second column and third column. Here the diagonal element A33 is equal to minus 1. In order to make this element A33 equal to 1, we should multiply this column 3 by minus 1. Minus 1 multiply the minus minus plus 1 0 0 0 0. See third column se minus the multiply to sinner. Minus the multiply to the 0 0 ko. This one will be equal to minus 1 plus 3 should be equal to plus 3. And for any square matrix A, this A multiplied by this matrix is equal to identity. Therefore, inverse of A will be equal to 2 0 minus 1, 5 1 0 and the 0 minus 1 plus 3. This is the inverse of square matrix A. For today, let's end here.